Hey everyone, it's Mr. Wolfe here, and in this video I'm going to be going over example 1 on page 41. So if you haven't already, make sure that you get the notes on this target sheet right here. There's a video on it, so if you haven't watched the video and you haven't completed this, make sure to do that. But let's go over an example problem actually applying these equations. So here it says you accelerate from rest at a rate of 3 meters per second squared until you reach a velocity of positive 45 meters per second. How much time does that take to happen? So the first thing I want to do, and there's not a lot of space here, this is for the equation, but we're also just going to write down all the things we know in this box too. So for instance, it says that I accelerate at a rate of 3 meters per second. So I'm just going to say my acceleration is 3 meters per second squared. And then it says that I reach a velocity of 45 meters per second. So the fact that I'm reaching that velocity, I could either have an initial velocity or a final velocity. Since I'm reaching it, this would be my final velocity. So 45 meters per second. And then it says that I'm looking for time. It's always important to just kind of write what you're looking for, because sometimes you get into the minutia of everything and you forget, what am I actually solving for? Okay. So what I could do now is I'm going to look at this sheet and I'm going to say, okay, am I going at a constant speed or changing speed? Well, I'm accelerating, so I'm changing speed. I know I need to use one of these three equations right here. Okay. And if I look at them, I know that I wasn't given distance in the problem, so that kind of rules out this equation. So it's really between these ones. So I'm going to use this. I mean, you could use either one, by the way, but I'm going to use the top one for this example. So final velocity is equal to acceleration times time plus your initial velocity. And all I'm going to do here is substitute variables in. All right, so for my final velocity, I have 45 meters per second. My acceleration is 3 meters per second, or 3 meters per second squared. I'm solving for my time, but I need to fill in something for my initial velocity, and it doesn't look like I have another number up here, so what do? I can't solve this equation if I have two variables. But what we could do is we could read into the problem. You're not always going to get an exact number. You have to kind of figure things out by looking at the context. So what I mean by that is you accelerate from rest. So if you're accelerating from rest, that's your initial velocity. It's just 0 meters per second. So we could just plug in 0 here. Now we could solve for the time. So I'm going to divide 3 by both sides, and you're going to get a time of 15 seconds. So that's LT1A, using word problems. Now let's go to LT1B. And I'm going to show both methods for proportional reasoning right here. So the first one I'm going to show is the one-to-one method. As things start to get a little bit more complicated with our equations, this might be a method you choose, but either one works, actual numbers or one-to-one method. So in my one-to-one method, I'm just going to write to the side that here's my original situation. And you don't need to do this every time, but I think it's helpful in just explaining it to you all. Oh, by the way, we use this equation up here, right? But then if we go back to our sheet, I could use this for proportional reasoning, but it's a lot easier to use the rearranged one. Delta V is equal to AT. So that's the equation I'm going to use. And it says that by what factor would the time change? So this is, I'm just going to put a question mark, like this is what I'm looking for. Acceleration stays at the same rate, and my velocity, I'm going to just draw like an arrow towards it in terms of this is what I'm changing. I'm making my velocity 3 times greater. So in my original situation, I'm just going to plug in the easiest values I can. 1 times 1 is equal to 1. Now I'm going to go to my new situation. I'm going to use my equation, same equation, but now I'm going to say, okay, well, 3 times the velocity, 3 times 1 is really easy, right? It's just 3. And my acceleration stays the same. It was 1 before, so I just put in 1, and I'm solving for the time. So when you do the algebra on this, it's really easy. Your time is equal to 3. And notice that there's no units or anything. We just put an arbitrary value. So what that's telling me is that time would increase by a factor of 3. So there's my answer. So that's why the one-to-one method could be really nice to use. It's fairly easy. All right, but let's do the actual numbers too. And with my actual numbers, let's see, I'm going to use the same equation. Change of velocity is equal to AT, okay? And it says that my velocity is becoming 3 times greater. Right? So if I think about my change velocity, I went from 0 to 45 meters per second. I had a delta V of 45 before. Right? And I'm going to take that, and I'm going to multiply it by the factor of 3. So that's 45 meters per second times a factor of 3. And that's going to give me 135 meters per second is my new velocity. So let's plug that in, 135. And then my acceleration from before was 3 meters per second squared, so 3. And then I'm solving to see what happens to the time. And my time ends up being 45 seconds. Okay. Now, if I'm doing the actual numbers, I haven't solved the problem yet in terms of what it's asking for. It's asking by what factor. So what I need to do is I need to take this new value and divide it by the original. So my new value was 45 seconds. The original was 15 seconds. So that's going to give me an answer of 3. And that's just saying what we got before, that my value changes by, or my time would change by a factor of 3. So we get the same exact answer, just in a different way. All right, so then for the last question, what kind of mathematical relationship do we have? Well, our velocity increased, and so did our time. So this would be a direct relationship. All right, so hopefully this walkthrough on example 1, page 41 was helpful. Thanks for watching.